It doesn't matter what method I get. It's what you're really doing.
Oh, yeah.
Hopefully, I think I can find a light.
Yeah, that's
good. And then like,
That's why you said.
I can.
Oh.
Because
We'll see.
that's the outcome.
Yeah, I do. Bring that. I have the advice.
Let's go to page 6 in your packet.
I know.
You got to do that. You didn't check it. Oh, yeah.
I'm not.
dollar legging.
You are. The age of 8.
Let's go down to 8 and 9. So for 8, we're going to 8 and 9. We're both gonna both problems. We're gonna sketch the graph with the given characteristics. Let me just highlight a few things, and then you guys, we can try it together, or you can try it, and I can also do it at the same time as you do, and then we can compare our answers. If we're finding limit as x approaches a number, we know that is talking about a full limit. So I like to always start off with a whole. Because I don't want to overcommit and plot that point and later on find out that point is defined elsewhere. So I like to do a whole here. But some of these problems are one-side limits, so it only needs to approach that y value from either the left or right side of their target. Part C, the limit exists, so I like to do a whole with kind of segments that extend out from the whole from both sides. If a limit doesn't exist, you have 3 options that you can do. You can either create a non or a jump discontinuity. You can create a vertical asymptote, or you can make the graph an endpoint and not pick up on the other side. Okay. If we're approaching a real number and it's going to positive or negative infinity, you know that this must be talking about a vertical asymptote. And that negative infinity is indicating that there's going to be a common behavior on both sides of the asymptote. Thank you. But if we're approaching infinity or negative infinity, this is talking about what? Horizontal asymptotes. That means that as you exit the graph to the left or to the right, you want the graph to hover around that horizontal line. So that means as it exits the graph, you want to eventually have the arrows flatten out at -6. Over here, this is telling you that you want the graph to eventually flatten out at a y value of 8 as the arrow exits to the right of the graph. Okay, so see if you guys can start putting this together. I have a version of the key on the next page, page 8, but go ahead and try it first. Your graph may look different from mine, but after you graph yours, you can check that, or and then we can go over it together. Right. And I can also walk around as well, since not everyone's graph may look the same, especially if the limit doesn't exist. But let's just see how we do. make sure that after you, you completed a draft of your graph, make sure you go back and look. Is any part of your graph failing the vertical line test, right? I should be able to, I shouldn't be able to drop a vertical line anywhere and hit more than 1 point. You have a couple options. You can make it a vertical asymptote. You can make it purposely disconnected, or you can make it an endpoint. Okay. So I made mine an endpoint, but you can make it as a vertical asymptote. Oh, let's see. Oh, I'll think I can do that. 3 from the right. Oh, yeah, you're right. Oh, yeah, it could be just be from the right side, but I just made my graph go right through that point. I'm doing more than I need to. Could also just have my graph stop right there if I wanted to. I didn't need this piece.
The point is -4, -3, like, do you have to have it as a whole?
No, but I like to start off with a hole because there may be something else that's telling me to plot the point elsewhere. So to me, that's the safer thing to do. But if you made a continuous function and there was nothing else to find elsewhere, then that's fine as well. But that's just my preference. If I ever see a limit exist, I'm always starting off with a hole because I'm afraid that maybe there's something else that is defined elsewhere and I got to erase it. So that's the only reason that I always start off with a hole. Everybody okay with 8? Yeah, your graph doesn't have to look exactly like mine, but there's some variations, especially with a limit doesn't exist. Like try 9. right, check number 9. Okay, your graph looks different than mine, and if you're unsure whether it's correct, raise your hand, let me know, I can come around and double check your graph. Distances, so we have to create other distances. So either make it disconnected, make an endpoint or for a class. Okay. That's one, yeah, just make sure it's drop this content. And everybody okay with 9? All right, let's go to page 11. 11 has a mixture of different content. Let's start off with number 3 first. Let's review intermediate value theorem on page 11. Okay, so the whole point with intermediate value theorem is asking, can I guarantee that my graph is going to go through that y value of 2, just relying on a couple of minimal pieces of information from the graph and without looking at the graph. So what we first need to establish is my function continuous on the interval? So we want to look at our function and determine, wait, are there any holes or asymptotes? And if there is, are the holes and asymptotes going to interfere with my interval? If it doesn't interfere with the interval, then great. You can just say function is continuous. You checked it. You don't have to go through a whole lot of explanation as to, oh, the asymptote is here and it's outside the interval. You can kind of just do a visual check and convince yourself that a function is continuous or not continuous through the interval. If the function is continuous, then you can go on to your next step. If the function is not continuous on the interval, then you stop the problem and say function is not continuous on the interval, therefore IVT does not apply. Right. So first establish that the function is continuous on the interval, write out that statement, and then move on to the next step. The next step is doing direct substitution with your endpoints and seeing what you get for your y values. So here you'll plug f of 4, find f of 4, find f of 8, and the hope is that one y value will be above 2 and the other y value is below 2. That way, if the function is continuous, and if I'm starting at a value above 2 and below 2, and there's no breaks in the graph has no choice but to eventually cross through a y value of 2 at least once, and that will be your reasoning to determine if IVT, or if we can guarantee that f of c equals 2. And then if you're able to get all the way down to those steps, convince yourselves that f of c equals 2 somewhere along the interval, then it says find f of c. Sorry, find the c value. So basically it's saying, okay, if I know that my y value of 2 is going to be reached somewhere along the graph, where is that x value going to be? So how will I find that x value? Yeah, I just put that 2 in for the y, and then you will solve for x, however, right? If you get multiple x's, what do we have to be careful about the location for your c value? Make sure it's inside the interval. You can have multiple locations where the graph is going to hit a y value of 2, but we only care about the interval. So you're guaranteed at least one, but if you see more than one, just be wary, because that other one may be outside the interval. If it's outside the interval, you want to remove it. It's not going to be a valid c value. Okay, so go through number 3, and I will work through at the same time that you guys do. I made a statement about my continuity. I did direct substitution for my endpoints. I confirmed one endpoint is clearly above 2, the other endpoint is clearly below 2. And I'm establishing my relationships here, that my endpoints are producing the y values that I need. They're both on either side of my target y value of 2. And then once I've confirmed that there's a C value that's going to live between, that's going to be guaranteed, I'm now looking to see where that order pair is. What X value right, I check for continuity by looking for asymptotes and holes. I did find one, but it did not interfere with my interval, so I can safely say my function is continuous on the interval. All right, let's go ahead and try the rest of page 11. I think the top of the page is a good practice with piecewise function. Do we know what to do with infinities versus real numbers versus, direct substitution is first. And when do we play with decimals, right? So all those things mixed together, can we sort through all those steps and still be okay? For part B, you're going to walk through your continuity conditions. So practice, see if you can remember your continuity conditions from memory and practice writing out each of those conditions in the proper notations that's required for continuity conditions. Number 2, find horizontal asymptotes. There's a potential for split asymptotes. So now make sure that when you find a horizontal asymptote that you don't just say the limit, that you are actually saying y equals, right? If it's asking for a horizontal asymptote, you have to make sure you name the equation of that line, not just the number. And then number 4, this is the easier version of the one that we did before, where you're not creating the graph, you're just looking at the graph and identifying the values or properties. Okay, all right, so try that. I'll walk around, see how you guys do, and then you can also check your answer on page 12. 12 is the key. That's a comma. Yeah, negative x squared, x 12x plus 2. Yeah, that's it. Yeah, there's that. It's not a x law. Just direct substitution first, and then substitution. We're going to negative 7, which means that there's a point left. So which means that there's a was it? That means you have to like decimals again. If you get 0%, then you're expecting. Yeah. This is not, the erase this, right? They go up, yeah. Yeah, you can look like this one. Yeah. Yeah, but it says. Possible, yeah, that's totally what I took. And if I just made my graph whole city. Yeah, I kind of made my graph whole city. Yeah, actually, I just sort it down. Yeah, I mean, it was like that pretty good deal. So, oh, okay. Thank you. Show this one. This one is next to the left, right. So, what I particularly on there, how to do it first. You go through your steps, right? Your steps is direct substitution. Okay, so even though it's less than -4, I'd still put. Because if we're approaching -4 from the left, this is to the left of -4, so this is still valid. Okay, so I put 4. Yeah. Okay, but I'd have to take out. Well, what does it tell us though? What does that tell you? That there's something to do this. No other. So that's not going to work. What indicates a hole? So 25 over 0. What over 0? What's 25? What's happening? We don't know. Trying to stick with this. So there's no hole here. This comes the acid. How do we handle what's that? Yeah, so you plug in something. You know you're either deciding between positive or negative. So you're only gonna they're gonna go through factoring and all that. If you don't get 0. I said don't get 0 for 0. 25 to 0. Think about this. 16 minus 97. So that would be -7. Yeah. Again, that's fine. You can see that this isn't gonna go anywhere. We already said that. I did not think it's so bad. You don't factor. Yeah, if you factor over 0, unless that means either positive or negative infinity. So you play with decimals. That's right. That means that's right. Either positive or infinity, and you'll use decimals to help decide between those. You use the factor form to help us out, basically. You wrote it down.
But in order to both sides, right?
X plus 4 and the -4.
But they are.
This one is going to be.
If you're done with page 12, just continue with the packet. I just have miscellaneous reviews. Now you're just doing as much practice as you can leading up to your test on Thursday. So the key is attached. Let me know if you have any questions. I'm going to walk around, and if you have any trouble with any parts of the problem that you're going through, let me know. I don't want to. Okay. Remember, if you're approaching negativity, you got to switch gears. You got the 30 degrees.
Oh,
Right, I know, it's like, everything is mixed, so you gotta, yeah.
I don't have
These-
thought
yeah,
of.
I know, these two, you have to do degrees, and the others, direct substitution.
Okay.
Yeah.
I'm gonna just let block it. This would be.
I use it for all of my notes.
I just had a question. Yeah, so, it was on this one, right, too. So, there were questions like, let's say,
I mean, if you just go there, I'll get what,
41, right?
Mhm.
So for these two, put in the decimals, correct? This is your final response.
We first do direct substitution.
So it would be 1/0.
And then that convinces you that there's vertical asymptote, and then you can do decimal.
So if there's a vertical asymptote, then you solve it by,
Well, if it's a vertical asymptote, you know the limit doesn't exist.
yeah.
And then if you realize, oh wait, it's only asking for the one side limit, then you switch gears to test between positive or negative. So you gotta do decimals to decide between those.
Okay, so what are the decimals, right? So I would, the difference would be 2.9 and 3.1, right?
This is, well, to the left of -3, it's between -3 -3.
Oh, yeah,
Because everything is opposite, yeah, because it's a negative.
so then I would just be like 3.1,
-3.
negative 3.1 squared, right? Minus 9.
And if you look at the signs above and below.
Okay, so 1, then this would be more than 9. So this would be, positive.
So positive.
Oh, yeah.
Positive.
Positive. So, and if it would be negative, it would be negative.
It's positive or negative.
And you won't get 0 here, or just a decimal.
Exactly, yeah. Once you realize there's a vertical asymptote, it's either positive or negative infinity. Those are the only two.
And on the quiz, there be, the test, yeah. The test will there be on the sine, cos, process.
No, there won't be. Let me confirm. I don't think there will be.
Yeah.
Or if there is, it'll just be direct substitution and then using bubble circle.
Yeah, I'll probably have to memorize. Okay. Yeah.
Okay. And then with this one, 41, you just need to sketch the graph.
Okay, so I've just fetched the graphic.
That's long enough. That's all. This is at vertical at -1. And if you follow the graph to the left, it's gonna go down.
Okay, perfect. Thank you.
So the first thing I did is direct substitution. I got the inside of which tells me that there's a vertical asymptote. That it doesn't exist. However, it's approaching just. So I know that, I got to test positive, I got to test on decimal values, side of the positive. I just chose negative.
I think that- That's where, somebody has called that.
We can't shoot that this one. Can't shoot that. Or sorry. We can't shoot that. You guys. What's the use of the phone line?
I couldn't figure that.
The way here was still. It wasn't my dad. So it's just. You guys know how that is done. That's the sign.
I just don't know how you got 1/2 in the first place. I'm just overcomplicating everything.
Yeah.
Yeah, no, I'm
It's showing opposite sides, but it's going to be between those.
Okay, wait. Oh, good.
Talking about. Barely. Yeah, I had it now. So you're like, that's Alright, so you got two. One that should be on the ice line, it's just a bit of the below.
There's so much of them.
Yeah. Francis.
I just need to go for that.
Guys, if you want to talk, make it fun. Make it fun.
Okay, so if we're done with 11, go to page 13.
College admission. How to get prepared for. How to get all of this basis. Like, obviously, when they're here in high school, it's like. Like, it was like Tues. Unless you don't. So this was.
I'm talking and negative just stays.
Yeah. It'd be funny if he wants to ask me. And be on it. Okay, sure. So, some of the recognition. Take something like steps. Yeah, take steps. I'm doing it again. It's bad. It's still right. Why wait? This one to go. Space that he's gotta have.
It's so, it's such a fun board. They're almost. These are curious, like really.
Bro, what are you yapping about? Yapping about waiting.
I wouldn't say really. I know it's supposed to get like way harder very quickly.
Alright, anyways.
You should take it.
You're right. Both technology and they're exactly the same. They're not. They're not variations of each other. Exactly. But the college is. Oh, it's not amplified. Oh, it's a real word. It's not. Oh, that'd be awesome. I'm still like a negative. I'm still getting the negative. Yeah, I'm pulling them up. That's a lie. No, I'm not. I'm still. Always. Oh, that's a big. Actually. Negative. I'm taking results. I don't want to get that it's only negative. Because it's nice to turn.
Was it like for
But I'm not gonna- this is kind of like strange. Yeah, it's unless you're going to like a mid, like a state, like GM or like channel something.
You get a big.
Guys, page 16, number 3, this is really a strange variation of horizontal asymptote. There's only one horizontal asymptote because whether we test positive 100 or negative 100, we're never going to get other than a negative. So this is only going to be one horizontal asymptote. But I won't give you one as complicated as this. If I give you one that involves split asymptotes, it'll be like a square root. It won't be anything involving like a cube root. So yeah. So don't let that stress you out. I'm not gonna give you any ones that are outside of the ones that we went through in class.
these are all live?
Yeah, I know. It's always positive and negative. Nice rational function.
Or not.
If the equations are the same, it's always going to be the same. Yeah. You see, even things. Trying to stop that. Yeah. You got to stop. If you stop, no, you were. You were talking.
So, no, yes, that's.
I already said.
Every senior hates also. I mean, I already took.
You guys will see it again. Yeah.
Just like, like that, like that's the state.
So I think I get it, but that's. You need to start finding. Yeah. Okay, that's good. Yeah, we gotta start writing eventually. That's. You also have it. Oh, is it right now? Yeah, right. They go like. Well, so I think it's better than that's not. I thought for there's one more.
Okay, so tomorrow, we're going to start notes with unit 2. But it still gives you an extra day to review. I will have a help session tomorrow morning. If you have any, or more like, if you have any questions, we can go over any questions in the packet. And then Thursday morning, help session, I will be going over the last test review in your packets. I think it's after page 25. I didn't put a page number there, so I think around like page 26. But I do encourage you guys, if you have time, that you're using Wednesday nights as, going through this as your mock test. And then Thursday morning, if you want to attend the help session to ask questions or to sit in, but I will send a Teams link where you can join virtually if you like. Any questions on Wednesday? I'm sorry?
Is there a help section?
Yeah, tomorrow I'll have a help session, going over anything that we haven't gone through the packet. All right, in a minute, I'm gonna let you guys get your phones. I'm gonna talk about what's gonna happen with Tuesday, Wednesdays, and Thursdays. So at 10:11, we're gonna switch over to advisements, and during advisement, you may have to do like student success skills and those PowerPoints and things like that. But Mr. Hosha is going to be actually with your class or with this class during that time period. So Tuesday, Wednesdays, and Thursdays, he will do the advisement time with you. All right, come and get your phones.
Are you teaching? Are you teaching?
It's so good though.
How does that man? Might be.